Hi madam. Hello everyone. My name is Loknath Reddy and I'm presenting my project titled AI based air quality analytics and predicted prediction dashboard. And here the main objective is the project is to analyze air pollution patterns in Beijing predict PM2.5 full pollution levels using machine learning techniques. And the project combines environmental data analysis, predictive modeling, and web application development into one intelligent monitoring system. The dashboard was developed using Python, Flask, Skitlan, and HTML, CSS, and JavaScript. The final application was successfully deployed on the Render platform, and it is a cloud platform for the real-time accessibility and demonstration purposes. And this project demonstrate how machine learning and software engineering can be applied to solve real world environmental monitoring problems. Okay, here I can able to share my screen and I can explain my objectives and all. Okay, and here the my and motivation and objectives. Air pollution is one of the major environmental and public health problems worldwide. High pollution levels can cause uh, high level like respiratory diseases like lungs problems, and also there is a lot of environmental damage as well. Beijing is one of the cities that explain the severe air pollution due to industrialization, transport emissions, populated growth, and weather condition. Because of these environmental challenges, I selected as my with my project topic. The main objective is of this project is to analyze environmental pollution data to identify relationships between weather conditions and pollution levels, to compare machine learning models for pollution prediction, and to develop an interactive Flask dashboard for the real-time prediction. This project also helped to move my practical skills in data processing and machine learning, data visualization, and software development as well. Okay. And here we are going to deal with the data set and data handling. The data set used in the project contains Beijing air quality data collected from four monitoring stations. Those are Dongxi, Gonian, Changping, and Huryu. These are I took as a four data sets. Two are from the urban and two are from the rural areas. Okay, and here the data was collected between the 2013 and 2017 and contains environmental variables such as PM2.5, PM10, temperature, pressure, wind speed, and rainfall and dew point. And here PM2.5 and PM2.10 are air pollution indicates in my application. PM2.5 represents very tiny harmful practicals that can deep into the lungs with, while PM10 represents the larger dust particles in the air. Lower values indicates better air quality and higher value indicates the polluted conditions. Okay, and then yeah, I can show you my Google Colab as well. Uh, Here I took the four cities with the data set. Okay, I can show you those data as well. Okay, I kept my data set in the drive and I did the mount as well. And these are the four cities I selected. These two are Dongxi and Gonian are the urban stations, and Hevreyu and Changpin are from the rural stations. Okay, and I ran this code in the Google Colab as well. And the exploratory data analysis. Exploratory data analysis, also called EDA, and was performed understand pollution behavior and environmental relationships. I used several visualization techniques such as histograms, heat maps, scalar plots, monthly trend analysis, station comparison charts. The analysis shown that PM2.5, PM10 values were highly right skewed with some extreme pollution events. And here the correlation analysis revealed that PM2.5 had that means the strong positive correlation with the PM10 and a negative correlation with wind speed. And here the whichever the machine learning models I used in my project. For pollution predictions, I implemented and compared three machine learning models. That those are linear regression and decision tree regression, and as well as a random forest regressor. Linear regression produced the limited accuracy because environmental pollution data contains complex nonlinear relationships. Decision tree regression captured nonlinear patterns effectively but suffered from the overfitting problems and poor generalizations on unseen data. And random forest regressor achieved the best performance among all the models because it combined the multiple decision trees and improved predictions stability. And and I'm going to demonstrate my application development as well. Here, my application development is now I'm going to demonstrate the Flask based environmental analytics dashboard. The dashboard was developed using Flask for backend development, and I also mm, deployed my application in the render platform as well. It is a cloud-based platform, and Flask for the backend development, HTML, CSS, JavaScript for the front-end design, and skitlearn for the machine learning integration. Recently, I am learning this skitlearn for the machine learning models I have used in my application. The dashboard allows user to enter the environmental parameters such as temperature, pressure, dew point, rainfall, and wind speed. And also I had mentioned my the levels, the ranges whichever my application is allowing to take the inputs. As here I mentioned like this the temperature limitations and the pressure limitations, and as well as dew point, rain, and as well as the wind speed as well. Okay. And I had deployed my application in this render platform. You can able to see my application in the render platform, and I can able to mention the application URL as well in the PPT slide. You can able to go through that video and the video application, and as well as the application URL, and as well as the GitHub also. And I had deployed my all the codes in this Git repository, and you can able to see my this templates and data stores and IPYNB file app.py. And I can show you how I run my app.py in the Visual Studio name. In this path, I had mentioned my app.py application code thing, and I had run my Python app.py. I ran my Python application, the py application, and here we can able to generate this URL, and this URL can able to by this URL you can able to open the my application. Yeah, we can able to see my application, and I can able to demonstrate how we can able to give the values like with the good values and moderate values. Okay, suppose we can able to enter the temperature as 20, and pressure as 1018, and dew point is 8, and rain is 3, and wind speed is 6. And we can able to now predict the PM 2.5 around 10 to 40. See, predicted PM 2.5. This air pollution is now it's good. Okay, and we can able to take the moderate values as well. Moderate means it's a medium. It's a medium values. Those are suppose 31 as a temperature and 1014 as a pressure, and dew point is 18, and as well as zero rainfall. If the rainfall is um, zero and wind speed is good, right? So then we can able to predict this one as well. See, this is the like moderate value, like not the good one. Okay, and we can able to predict the extreme pollution as well, like 48 as a temperature, and 985 as um, pressure, and 34 as a 34 as a dew point, and rain is 0, and wind speed is 1. See, it is also like hazardous one, not the good one. Okay, and we can able to check the whichever the values in my application. And I had mentioned bar plots, scatter plots in my Google Colab link as well. You can able to go through it, and yeah, yeah, I can able to show you all the things in my this. And in the version control and challenges, I have the whichever I had used, right. The GitHub version control was used throughout the project for the project management, code tracking, debugging, and backup purposes. Version control I helped to organize development stages and maintain project consistency during implementation. Several challenges were encountered during the project, including, missing environmental data, skewed pollution distribution, deployment debugging issues, model optimization, and Flask integration problems. And for this, in the Google Colab link, I had uh, I had uploaded my data set in the Google Drive link, so that we can able to connect with the drive, and we can able to get the data from the uh, drive with by using mount option. Okay, and here the critical reflection and all. In this project, improved my practical understanding on the analytics, machine learning modeling, Flask application development, and the software deployment. Although my project achieved the good prediction performance, there are several future improvements that can be implemented. Integration of live AQI APIs and deep learning models with the high accuracy, and IoT sensor integration, and mobile friendly dashboard development. This so that we can able to see, you can see my application is like a user friendly environment with these ones. And if you suppose, if with this one is, we can able to see the this bar plots and all as well, and we can able to predict this PM2.5, PM10, and this NO2, CO2, and O3, and these all. Okay, and finally, my conclusion is, in the conclusion, this project successfully combined with the data analysis and machine learning and software development into practical environmental monitoring system. The project analyzed Beijing pollution data, identified important environmental trends, and developed a machine learning based prediction dashboard. Among all machine learning models, random forest regressor achieved the best prediction performance. Uh, Here I faced some of the difficulties to deploy the code into Flask one. After that, I realized that I used this one, and I deployed my application in the render platform, and I'll mention my application link as well in the PPT session heading slide. So this is the overall project of my academic application development for the programming for data analysis. Thank you. Thank you all.